Hello my young friends, I am Naveen Sharma and I am going to help you in learning class 12th chemistry. Now, to increase third, to increase the solubility, of CO2 carbon dioxide in aerated drinks, your soda water or cola, in aerated drinks, these bottles are sealed under high pressure. Bottles are sealed under high pressure. Okay. So, these are the applications, three important applications of Henry's law. Several times have been asked in your CBSE board exam, condition of bend. Okay. Now, after discussing the applications of Henry's law, now we are moving towards the next important topic. Now, the next important topic is called Raoults law. Or before discussing the Raoults law, we have to discuss this vapor pressure. Now, what is vapor pressure? What is vapor pressure? You know, like there is a container in which liquid particles are present. So, large number of molecules are there, they hit each other and also to the walls of container. So, there are large number of molecules which are in random motion, so they hit each other and also they collide with the walls of container. So, some molecules will have higher kinetic energy, and some will have lower kinetic energy, as their kinetic energy will change when they hit each other and to the walls of container. So, some will acquire more kinetic energy and some will have lower kinetic energy. So, the molecules with higher kinetic energy reaches at the top of container, at the top layer of container, top layer of liquid, top layer, they break the force of attraction and escape. So, this is how vapors form. Okay. So, is that clear? The full story, there are large number of molecules present in a container, they are in random motion, they strike with each other and also to the walls of container. Now, some molecules will get more kinetic energy, some will have lower kinetic energy. The molecules with higher kinetic energy, when they reach at the top, they break the force of attraction. So, they break the force of attraction, this is right and left, below. They break this force of attraction and escape out as vapor from the solution. So, this is how vapors form. Now, if this process occurs in a closed container, then what will happen? Initially only evaporation will take place, so few molecules are there. When these molecules strike the wall of this wall of container, they lose energy and finally fall back into the solution. So now initially what happens? Initially the evaporation is more and only few molecules came back into the solution. After some time, what will happen? The population of vapors increases, and now more number of vapors will come into the solution again. So a state reached where rate of evaporation or vaporization becomes equal to the rate of condensation. What is condensation? When molecules lose energy and they fall back into the solution. So a stage comes when the number of molecules reaching at the top of container, equal number of molecule will fall back into the container, means the rate of evaporation or vaporization becomes equal to the rate of condensation. At this stage, if we arrange or attached a pressure gauge here to measure the pressure. Now the pressure in this pressure gauge, when the rate of evaporation becomes equal to the rate of condensation, is called vapor pressure. Okay, so we can define vapor pressure: the pressure exerted by vapors. How we can define vapor pressure? We can define vapor pressure. Vp is vapor pressure. The pressure exerted by vapors over a solution in equilibrium with liquid at given amount. Equilibrium with liquid at a given temperature. So I hope the story of vapor pressure is clear to all, how vapors form and what is vapor pressure. Okay. Now the vapor pressure depends on what factor does this vapor pressure depend? Listen, vapors are formed from liquid only. Okay. So on what factor does the vapor pressure depends? First, the nature of liquid. If the intermolecular force of attraction, means the force of attraction between the molecules of the liquid itself, if the intermolecular force of attraction is more, vapor pressure will be less, because if liquid particles attract themselves with a larger force, then they need larger energy to escape out, and if there is a weak force of attraction between the molecules, then they can evaporate or vaporize easily. So vapor pressure is inversely proportional to the intermolecular force of attraction between the molecules of the liquid. Clear? Okay. Like if I talk about ethanol and glycerine, glycerine or glycerol or ethylene glycol, they all are same. What is ethylene glycol? CH2OH, CH2OH. Now this contain two hydrogen bond. Ethanol is what? C2H5OH. A single hydrogen bond is there. So the more force of attraction is present in glycerine. More force of attraction is present in glycerine because there are two hydrogen bonds are there, and here only one hydrogen bond. Therefore, vapor pressure of ethanol will be more than the vapor pressure of glycerine. Okay, because the molecules of ethanol can vaporize more easily as compared to the vapors of or the molecules of glycerine or ethylene glycol. Okay, clear? Then second we have second factor, we have temperature. Now vapor pressure will be directly proportional to temperature, because when we increase temperature, the molecules will acquire more kinetic energy, and when molecules will acquire more kinetic energy, they will easily break the force of attraction of neighboring molecules and can escape. Clear? Yes. So vapor pressure is directly proportional to temperature. Now we have discussed the vapor pressure of a single component or a single liquid like glycerine or ethanol. Now what will be the vapor pressure of solution in which two components are there? Vapor pressure of solution. Vapor pressure of solution. In this we will study Raoults law. Raoults law. Okay. Now we will study two type of solutions. Solutions containing non-volatile solute and volatile solvent. Now what do you mean by volatile? Which can vaporize, which can evaporate. So we are taking non-volatile solute like sugar or salt. They cannot evaporate, they cannot go into the air. Okay, and a volatile solvent like water, alcohol, which can evaporate or go into the solution. And the second we will do solutions containing volatile solute and volatile solvent. In this, both solute and solvent are volatile in nature. Okay, we will discuss them one by one under the heading of Raoults law only. In this meeting we are completing this up to here only. Then when will we meet in the next meeting, we will start solution containing non-volatile solute and volatile solvent. Okay, thank you so much.